Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. So I have an interesting experiment with one of my projects is that I'm trying to keep the issue tracker for the project within the code base of the project. And this is not a new idea of mine. I've been toying with this idea for as far as I can remember programming honestly. Right, because here's the thing. I remember using Git before GitHub was a thing. So, and for me, Git and GitHub is a completely separate thing, which is such a millennial thing to say, right? So because I suppose Zoomers these days, they don't really distinguish. Git is just like a command line utility for GitHub, right? So what are you even talking about? But Git originally was a version control system created by Linus Torvalds, specifically for Linux kernel, because the version control system that they used kind of like, blue balled them or whatever. Like, I don't know, they revoked their license or whatever. So I think it was called BitKeeper. Does anybody remember? I think it was BitKeeper VCS. Yeah, and it was paid at the time, right? It was paid at the time. And funny enough, at some point they actually finally like made it free, right? So which is kind of ironic, right? So what's funny is that they just didn't renew the license or something, so there was some problem with Linux kernel continuing using this VCS. Linus Torvalds just did his usual thing. He just blasted the market with the beam of his pure autism, and he created like a new VCS that took over the entire market. Now nobody fucking knows what is a BitKeeper. Like that's the Linus. Like if you mess with Linus, this is what he's gonna do to you, right? So it's just like it's like money versus autism. Autism will always win. Trust me, no amount of money will fucking save you. Linus Torvalds will sit down and fucking crush you by just typing code in a text editor. So do not mess with Linus. So yeah, so for me, it's always this version control system, and GitHub then came along as a sort of like a way to manage to host Git repos and stuff like that. And then they decided to add more and more different kinds of features, including issue tracker. And what rubbed me the wrong way about GitHub always, since the inception of GitHub, is that issue tracker of GitHub is a purely GitHub thing. So if in case of Git, it is very easy to just take a Git repo and push it to some other place, right? It's very easy to migrate a Git repo. If you start using their issue tracker or their actions or anything like that, like you can't easily transfer those things away. So, and that's kind of the main sort of like a hook. This is kind of the main vendor log of GitHub, right? So just they want you to use their issue tracker. They want you to use their actions so that you cannot just push a repo somewhere else. But what's interesting is that if the issue tracker was part of the Git repo, somehow migrating all of the issues would have been as easy as just pushing them to a different place. So, and I always wanted to have something like that. So, and I think like for the entirety of my career, I've been toying with this idea, and I couldn't find the right approach. So one of these such, implementations of this approach was, I suppose, Snitch. So this interesting idea is that you basically keep to-dos, so your to-dos in the source code become the issue tracker, right? So, and essentially, you can mirror them with issue tracker of your platform, but then if you migrate to other platform, you will be able to mirror them like to their issue tracker or something like that. But I feel like this project turned into like a complexity explosion. Right, and this idea of keeping the issue tracker with the source code never really went anywhere for me, unfortunately. So, and here is basically another iteration of the same idea, right? So it's another iteration of the same idea. So here is my project, and I have a tasks folder within that project, right? If you open this task folder, you'll see a bunch of other folders which have sort of like these identifiers. So this identifier format is rather simple. It's literally date and time. So it is akin to Twitter snowflakes, all right? So Twitter snowflakes or UUIDs. So essentially it's a unique identifier based on time. And what's interesting is that it has only 1 second resolution. And the reason why it has only 1 second resolution is because it's expected that it's going to be created at the human speed, if you know what I mean. Right. So essentially, it's not expected that this kind of IDs are going to be created very frequently at the scale of Google, for example. So as far as I know, Google Snowflakes, they have resolution of milliseconds. Plus, on top of the resolution of milliseconds, they have increments. So if within the single millisecond 2 IDs were created, so they result with additional sort of counters or something like that. So here, this is a very sort of like a low frequency IDs. Or the human level ID. So essentially, if UUID stands for Universal Unique Identifier, we're not trying to be universal, right? So this is something for your local needs. So I would say it's more like a human unique identifier. So I would call this kind of format HUID, блядь, сука. Got him. I'm sorry. So yeah, maybe like I should formalize this kind of format. So write some sort of like RFC or whatever where I say this is like a unique identifier, but it's specifically for a human frequency, right? So it's a human frequency unique identifier, HUID. So yeah, so we're using HUIDs. We're using HUIDs, which is just the date and the time at the second resolution. I have a description of this entire format of the tasks database in here. We're going to read it at some point. So essentially each folder corresponds to a task, and HUID is just an ID of the task, the current ID of the task. Inside of the folder, you have a file, which is a markdown file, and it's called task capital letters .md. So, and this particular file has rather strict format, so it has a part like some mandatory parts. So essentially, the first mandatory parts is pound and then the title of the task. Right, then the title of the task. And then it has properties, right? So it's basically dash, its status. As of right now, it can have 2 statuses, open and closed, right? So this is open right now. Priority is just like how urgent the task is. So it's usually used to sort the tasks by priority. So on top of that, you have an optional property in here, which is tags, and you can set additional tags in here, but you don't have to. So after that, you can put anything, whatever you want. So this format is designed to be sort of compatible with Markdown. So this is a mandatory part, and it accidentally, right, incidentally, you know, looks like Markdown. So you can treat it as a Markdown document, but it's just actually the format of this thing. So the tools that you write can easily parse all of this information and summarize this information. So the reason why each individual task is a folder is that you may want to actually attach some additional information to the task, for example, screenshots or the video or some other files, and you put that into the corresponding folder in here. And that way, here is your issue tracker. Right. So you're following this particular format of the database of the issues. You write some tools to help you to manage all of that stuff, and there you go. You have an issue tracker within your folder. So the usage of HUIDs is rather convenient in a sense that you can have maybe several people creating tasks at different times. Right, and it's very unlikely they're going to create the same task at the same second, though depending on the size of the team, it may become a problem. So it's very easy to merge these tasks. That's what I'm trying to say. It is very easy to merge. Somebody created some task, some other person created some task, they merge them together and no collision is supposed to happen. It may happen, right? So, and maybe because of that, HUIDs are not particularly great for this kind of stuff. Maybe I need to extend HUID with additional field in here, which is just a counter that resolves collision, kind of similar to Twitter snowflakes. But I mean, since I'm a single person, it's kind of like works for me. So it's kind of worked for me. So in here, I also have a little bit of a tools that help me to manage all of that stuff, right? So it's a very simple tools. And if I just like run this entire thing, it collects all of the information about all of the tasks, sorts them by priority, and just like lets me maybe jump to some of them. It just outputs them in a grep format, and Emacs recognizes grep format. You can click on one of these things and you can just like jump to one of the existing tasks. Right, so and interesting is that it sorts by priority. I can just take one thing and lower its priority, so it will actually go down. It's not on top anymore. I can bring the priority back, and yeah, so there you go. So then you can just go ahead and create a new task, hello chat, right? So here's the new task. You can go in there. It automatically created HUID for you, right? It created HUID and it created like this kind of thing. So it's set priority to 100, right? So, and then you can do something like ls. And there you go. So here is hello chat at the top. So, and if you then at some point close this task, right? So it is closed. It does not appear in this list anymore, but it's still there. And then you commit all of that stuff, and it also has history, so you can always get back to this issue tracker and stuff like that. So I do not plan to have any sort of official tools for this issue tracker, right? So what I want to do, I want to kind of develop a format, and I want the format to be simple enough so anybody can create their own tools to manage this, you know, format database. Does it make sense? So yeah, and here's the thing. I don't find using this command line utility that convenient, honestly, that convenient. There's a lot of things I want to be able to do. For example, I want to be able to jump to corresponding task if they're referred to. Throughout the code base, quite often, I just refer to a particular task. Like, look at that. So within the task, I refer to other tasks. And within the source code, I also quite often refer to existing tasks. I want to be able to, in Emacs, just like find these kind of patterns and Emacs literally click on them and jump to the corresponding file within the issue tracker. That's one of the things I want to do. Plus, I have quite a few to-dos, right? So which are outside of the issue tracker. We can find them. So here they are. I want to be able to, for example, here I'm standing on a to-do, and I want to say, okay, turn this to-do into a task, kind of similar to Snitch. So, and what it will do, it will find the task folder created there and maybe transform this to-do into task and then HUID, right? Something like that. So it makes it easier to just like turn to-dos into tasks and so on and so forth, right? So, and this is what I wanted to do today. I want to develop like a simple Emacs extension that will work with this kind of like a task manager, task tracker database within the Git source code. And I haven't worked with Emacs Lisp for quite some time already, so I'm a little bit rusty on Emacs Lisp. So we're going to do a little bit of research, a lot of Googling, a lot of exploring and stuff like that. I thought it could be an interesting stream. So what do you guys think? Sounds good? Sounds Gucci? Sounds Tamaguchi? So there's a popular format YAML. You can stop at this word here. You can stop at this word. I'm not reading the rest of your message. A little bit rusty, very Tamaguchi. It's like a stop word. As soon as you say these 4 words, I'm not listening to you. That's it. Like you lost my attention completely. So looking forward for go to HUID function. Yeah, exactly. This is what we're going to implement. So let's actually implement something maybe very straightforward, at least for now. Let's try to turn a to-do into a task, right? So that would be interesting. So here's the tasks. So let's create, we already have a tasks.c. Let's create tasks.l, L tasks. And this is stands for Emacs Lisp. So the thing about Emacs Lisp is that you can actually create some functions. So here's the hello world, and you can just do a thing like insert, you know, some text, or maybe let's say hello world. Hello world, insert hello world. The thing about this function, right, is that it just inserts hello world at the current cursor. I can evaluate the current as expressions, and as you can see, it inserted hello world. So the cool thing about Emacs, so here is your S expression. You can stand at the end of the S expression, and you can go ahead and evaluate it, and it just like performs that because the Emacs itself is an interpreter, of the Emacs Lisp. So there's something interesting. Is this something hateful? Like, I'm not familiar with Norwegian stuff or anything. So can anybody tell me, is this actually hateful? Because this is kind of weird. So is this like clankers misinterpreting something again? It is not hateful, right? So, okay, that's a bit bizarre. Which is false in YAML. Okay, so you can disable this. I guess I should disable this, maybe. So hate speech. Moderate. Let's keep it moderate, right? So I think it doesn't have to be maximum, right? So because that's kind of ridiculous. Fuck. The crimes of YAML. You know, your message was too YAML phobic, right? So hate against YAML. Committed a crime, hate crime against YAML. Oh man. Anyway, YAML lobby aware. So here what we can do, we can evaluate this definition, and now hello world is a function that I can just call, right? As you can see, I called it and it inserts the thing. So furthermore, you can mark this function as interactive, and it will appear now as a command in the Emacs buffer in here, so I can actually call it as a command, right? So I'm calling it as a command, and as you can see, it inserts hello world. So that's how you write Emacs extensions. And all of the Emacs extensions are just files which you just require or open or evaluate, and you can just use the functions from that file. So sometimes it feels like Emacs could have been written in Python, and instead of Emacs Lisp, you could have used Python. But Emacs is a very old application, so it existed way before Python. So can you imagine that Emacs is actually older than me? And I'm pretty sure Emacs is older than everybody in the chat, including me. That's how fucking old it is. So it's kind of interesting. So Emacs, GNU Emacs, Wikipedia. That's how old this motherfucker is. 40 years ago. Maybe not sure. Maybe there are some people who are older than 40 in the chat. So you're wrong. Okay. So glad to be wrong. Glad to be wrong. So here's the thing. I need to create a function. Let's do something like tasks create from to do. Right. So I'm going to evaluate this entire stuff. And the one thing I want to do, I want to be able to take a look at what we're currently standing on. I need to take the current line. Let me see. So as far as I know, there is a function. I remember think at point. Yeah, so here's the function think at point. And you can specify what kind of thing you're looking for. Think at point. And the thing you may be looking for is, for example, symbol, URL, email, UUID, by the way. You can have a UUID. Specifically, we're looking for line. Okay, so here's the line. So I can say I'm looking for a line. And we can print this entire thing. So let's say line, and here is the message. So now we have this kind of function. I can go back to maybe some of the existing code. I think I reverted these changes. There we go. And in here I can call task create from to do. And as you can see down there below, it says line, and here is the text of the line. Here is the text of the line. So what that means is that I managed to acquire it. So what I want to do is I want to save it to a separate variable. Let's actually put it into the line, and inside of this thing we're going to be able to work with this line. So is everybody familiar with Lisp, by the way? Because I'm just like coding in Lisp as usual, but maybe there's a lot of people who never programmed in this programming language and it looks weird as fuck. Which it is, right? I do agree with you, but you know, it's not that difficult to actually figure out how to use this kind of thing. So the language of God, I don't think it's a language of God. I think it's a little bit overhyped on that regard. It's just like in the majority of the situation, things like Emacs Lisp and Common Lisp, they're basically Python with a weird syntax. So it's a very much dynamic language. Right, so scheme is slightly different, right? So it's more like a dynamic Haskell, but Common Lisp and Emacs Lisp, they are rather closer to Python, like in semantic, right? They do have macros, you can manipulate AST and stuff like that, but still, ultimately, at the end of the day, it's just like a toy scripting language. It's just a toy scripting language. So essentially, it consists of lists. Right, so and list is something like this. So it's a bunch of atoms, right, enclosed by parentheses. And the name of the atom, by the way, can include things like dashes, right? So the tokenization of Lisps is usually way more relaxed than C-style programming languages, right? So things like this is a valid name for a variable and for functions and stuff like that, and this is a single function, so you can use dashes in here. So, and this is because it doesn't have an infix operators, right? So the way you call function is that the first element of the list is treated as a function name, and the rest arguments of the list are treated as arguments, right? And what's interesting is that lists can be nested, right? So here I'm calling function, let's say f, with arguments a, b, and c, and the result of the call to function hello world, because this function is the first element in the list, right? So that's basically how this entire thing works, right? So that's the syntax. So some things are not really functions. This is a special form. It defines a new function, so it's not treated as a function call, right? So it's sort of like a keyword. So one interesting special form that exists, it's let, and it's a let bindings. So, and if you take a look at let bindings, right, it's basically first is a keyword let, then a list of pairs. So this has to be actually 34, be 35, and so on and so forth, right? So this is the list of pairs. And then within this list of, within like the last argument in here, you can just use these bindings as variables. So that's what it is. This is let bindings. So you can evaluate this entire thing. As you can see at the bottom, it says 69. Might as well actually evaluate it so it inserts things, right? So this is 69. So that's how let bindings work. So what I did in here is that I got a thing at the current line, and I assign it to a binding line. Since it's a one single binding, it's a one single pair, but I can have more in the future, right? I may have more in the future in here, but as of right now, I just don't plan to have more. And that's basically how it works. And as you can see, after I bound all of these things, I'm just using this binding within this body expression of let. Right, I feel like it's kind of important to like clarify what this weird syntax means. Okay. So, and let me see. So if you're standing at here, so you get the line. If I stand somewhere where there is no, okay, so it's just like, yeah, it gives you always the line. So what I want to do, I want to match this line by a regular expression, because we need to be able to identify, okay, this is a to-do, right? This is a to-do, and we need to extract the title and stuff like that. So I suppose the regular expression we're going to be using is something like skip everything, skip the entirety of the prefix, put a to-do in here, then the colon, and here is the suffix. So in both of the cases, I think we need to save them, right? So that means this is going to be a captcha group, right? So that was weird. Can you just, yeah, thank you so much. So this is a captcha group. We're capturing all of that stuff, and we're also capturing this thing, right? So that's the regular expression. So then when we're going to be recreating the line with the task HUID, we're going to just like use the same prefix and suffix to do so, right? So let me see. So Emacs Lisp match string by regular expression. So I suppose the clanker is going to tell me how to do that. So here is the regular expression, and it's all useless, honestly. String match. Okay, so I feel like DuckDuckGo is doing like a Google thing where the search itself is shit, and they only let the clanker to do the quality responses. Right, I feel like they're doing this kind of stuff. So string match, what do we have? Yeah, there you go. So we can probably do something like a string match. So here is the regular expression. The string we're matching is line, and what it does, it returns the index of the start of the first match. Okay, so we might as well actually print this value, right? We can print this value, and this is going to be match, and this is going to be D, right? So I'm going to reevaluate this thing. I'm going to go back to here, and I'm going to just try to do that, and match is 0. So it's an index of the first match, which means that it is successful, right? It is probably successful because it matches the whole line. So if I stand in here, what's going to be the match? Format specified doesn't match argument type. That's very interesting. So it threw an error. It threw some sort of an error. Huh, that's bizarre. That is bizarre. So let me see. So what does it return? Something like maybe false, because I want to just do if it's true, return the index, or nil. Okay, so it may return nil. So when match, we do that, right? And when, by the way, is a version of if without else, right? So you can do if, here is the condition, then one single then, and the rest of the arguments are else. But then you can have just a single when, and it's just if without else. That's what it is. So if this entire thing matches, as far as I know, after that you have to call a different function, which is a match string. So, and it returns a string of text matched by previous search or regular expression. And you need to specify a number of the capture groups, because yeah, so we're doing the capture group in here. So you can say, okay, so this is the prefix. This is the prefix of this entire thing, and we could do match string first. So I'm going to do that, and let's go to here. Okay, args out of range, so 0, 7. Wait a second. I think match string also accepts the string that we were matching, right? So it somehow needs this stuff. All right. Argument type. All right. So maybe there is some sort of examples of University of Utah. Right. So is there something like match string? So string match. Okay. So here's the string match. Match end. The only thing I need is just okay, so match beginning. Is that what we need to do? Match beginning. Utah tiputa. Yeah, exactly. So wrong amount of arguments. Do I have to do something like that? Okay, so prefix is 0, which is weird, right? I mean, it only returns you the indices and stuff like that. I remember there was a way to get the data, and I feel like it was a match string. Does anybody remember? I think it was literally match string, but for some reason it doesn't really work for me. Return the string of, yeah, so string of text matched by previous search or regular expression operation. So, and it should just work for me, so I'm not really sure what it's all about. So I feel like your format specifier doesn't match argument type. So if I take a look at the message, maybe the message will, yeah, it doesn't give me more information. I'm an idiot, chat. Emacs, thank you so much. What a beautiful error messages. What a beautiful error messages. I appreciate Richard Stallman. Richard Stallman created GNU Emacs, right? So I should blame Richard Stallman for all of that stuff. Maybe I shouldn't use this shit, but I mean, I need some sort of like side effects and whatnot. So let's go here. Yeah, the goal. Here's the prefix. This is literally prefixes, spaces and slashes and stuff like that. That's beautiful. I think that's pretty beautiful. Okay, so and then we can have maybe some other things like message suffix, and in here we're gonna do match string 2, and this is the line. All right, so let's evaluate this entire step. I'm gonna do that, and let's take a look at the messages. Here are the messages, so the prefix was // and suffix check if flags have overlapping key bindings, right? So which is exactly what we have in here. Right. So this is kind of perfect. So what we can do, we can maybe actually bind them again, right? So they're going to be prefix. So this is our prefix in here. Boom. And this is our suffix, which is the second one. So what we can do now, we can maybe rebuild this entire thing. If I remember correctly, there was a function called format, which is like message, but it returns a string. So I can format. So here is the prefix, then I do to do colon and another prefix. So that's the thing. And then I can just like straight up insert this entire thing. So I can do insert. So in here I'm going to do prefix and then suffix. And what's funny is that I need to delete a particular, like a current line. Can I delete line? Why is it so slow? Yeah, I can delete line. This is perfect. So one thing I can do is delete line. So, and now if I try to do this thing, beginning, okay, I see. Toy scripting languages, by the way. Toy scripting languages. Okay, it kind of worked, except we need to do something like task, and let's say HUID. Right, so this is HUID. I'm gonna reevaluate this entire stuff. Boom, HUID. Though it's kind of weird, is that it removed a new line. I didn't expect that. So why does it remove a new line? Maybe because we have to also insert a new line in here. I'm gonna sneeze, chat. Thank you, everyone. Oh, so I have an allergy on this bullshit language. Holy fuck. Bless you, Zulu. Thank you so much, chat. I really appreciate it. So this is basically an average Emacs Lisp experience. Do you guys like it? Does it look fun? Right, so this is the so-called language of the gods. Right, so it's a divine language. If you learned this language and understood this language, you are God amongst programmers or something. Okay, I learned it. Money when? Money when? So I don't know, like for me it's just like a dynamic language. It's a dynamic scripting language. Still don't understand what's so special about it. Right, so I don't know. Common Lisp. It does feel like a Common Lisp, right? So it's also Lisp 2, meaning that the variables and functions are in two separate namespaces. So this is what CBT looks like, probably. God does not concern itself with money. That's an interesting phrase. That is actually an interesting phrase. So if I now reevaluate, what the fuck, Brevsky? What the fuck? End of file. Okay, so the cursor was in a weird position. It couldn't reevaluate this entire thing. Understandable. So boom. Imagine you actually stand on this line and you say, okay, create from to do. It goes into that folder. It finds that folder, creates the HUID task.md, gets HUID, and then just bam, and inserts it like that. And maybe even opens like a second buffer where it shows like what MD it created. I think that would be cool. So obviously it doesn't do it right now. We're kind of like a role playing, right? So what it's going to do, but it's kind of the goal. I think that would be actually pretty cool. So, and if it stands on something that is not to do, it will just do nothing, right? So because there's a condition to, like, you know, just ignore that. So we're matching a particular string, right? So when it matches, only then we do all of that stuff. If it doesn't match, we just exit cleanly. So absolute badgering. So we need to be able to create HUID, right? So task, new HUID. So how would you even generate a new HUID, chat? So let's actually see how C generates HUIDs. So .c, and like I didn't call them HUIDs in the code because I literally invented that name on the streams. So like I can't find it. I should have actually like invented it much earlier. I think it's a date time. So there was a command new. Let's go through the commands. So here is the new run command. Let's go in here, and this is how we create it. So we use a function local time, right? This is the local time, and we just like create this kind of stuff. I wonder if Emacs Lisp has local time. Do you have local? Okay. Do you have anything related to time? Date time? Thank you, Richard Stallman, for making it intuitive for C programmers. Right. Anyways, Emacs Lisp, get current date and time. Let's do this ritual of going to the Google and just, okay, so current time string, format time string. Okay, there is literally a function. Okay, so format time string. That is a poggers? A poggy woggers? Let's fucking go, my friend. Format time string. And what are we doing here? So we can just use the same format as in the local time of C. So I can probably grab... not really. Right, okay, so let me just copy paste this stuff. Let's just copy paste this stuff, and I'm gonna just put it like that. And I'm gonna remove all of these things. I'm gonna put dash in here. I'm gonna remove this stuff, and that should be it, honestly. Now, if I do tasks, new HUID. This is the new HUID. We can create more. We can create more. As you can see, I'm wasting HUIDs. I'm wasted limited HUIDs. Yeah, that's pretty cool. Which also means I can probably do something like this, and then can say, okay, tasks new HUID, re-evaluate that, and then boom, this is how it's gonna look like. Make time zone UTC, so it's currently using local time, right? So 23, 44, 25. I'm in Asia, essentially, right? So there we go. So it corresponds to that. Corresponds to that. How would it work across time zones? Very poorly. So, but at the same time, I'm a single user right now. So the definition of HUID doesn't include time zone. Maybe it should include time zone, as you actually notice. So maybe it has to be HUID, but in also UTC. That's a good addition to the definition of HUID. But again, HUID was never really defined. And it's actually kind of a stupid idea. It's very dumb and stupid idea. Because it doesn't, we don't even know how to even resolve collisions. Yeah, we need to write an RFC. Because you're right. We need to write an RFC. What I like about HUIDs is that because they are designed for a human. And I want to keep them that way because it is very easy for a human to also derive when it was created. Right. So that means it also stores the timestamp, so to speak. Isn't that cool? It is very easy to read. Even though all of the digits are smashed together, right, you still can make out that it was in 2025, right, in December 4th, and that's the time in 24 hours format, right? So, by the way, definition of HUID also has to be 24 hours format. That's very important. None of that 12 hours format bullshit with AM, PM, please, right? None of that. Anti-clankery, I think LLMs can understand that format very easily. So if we take a look at this kind of stuff, I'm gonna turn this ID into proper date time. So just like clankers have no problem understanding that, so I don't think it's that much of an anti-clanker. Anyways, so let's continue. Oh, this is this is a funny idea, right? So hardcode time zone to UTC plus 7. So UTC plus 7 is just like an OCBS time zone. that's so fucking funny, right? So yeah. So I propose new international standard. The time zone has to be the Novosibirsk time zone, please. So everybody in the world, please use Novosibirsk time zone. Do not confuse. None of that UTC. Novosibirsk time zone, bleh. I really like that. So, anyways, what we need to do. So we know how to turn to do into tasks, how to generate HUIDs. We need to find the freaking folder. Right. So, and how are we going to find the folder? I want to be able to find the folder from anywhere. Right, even if I'm deep inside of the repo, right, I still want to be able to say, okay, create to do. So the extension has to go up into the parents and just look for task. As far as I know, Git does kind of similar thing. So what it does when you do any of the Git commands, like have you noticed that you can do Git status pretty much from any folder within the repo. So it goes up until it finds .git, and then it just like uses .git. We need to do a similar thing. So Emacs list current folder. How to get a current folder. So okay, so this is not a good solution because Emacs has a very interesting thing, is that the current folder depends on the buffer. All right, so there's a function pwd which tells you the current folder of the buffer. But then if you switch the buffer that you're currently in and do pwd again, it's in a different folder. So in a sense, Emacs doesn't have a fixed working directory. It kind of switches the working directory depending on what you're looking at, right? So even on the cursor. So here is one working directory, right? This is one working directory. And I just click here and it's a different working directory. So it's kind of attached to a specific buffer you're currently in. So, and what I want is the current, can I just use pwd then, right? So since I'm calling this function already, I might as well just do that. So who said I can't do that? So maybe we can do define tasks, find database, find database. So in here, we can just do pwd. Right, so maybe I can go here, tasks, find database, boom. What a useless function, right? Okay. Okay, so that means it's purely for the user, right? It is purely for the user. What does it do? Oh, so, okay, so there is a global variable, default directory. It's a variable, default directory. So name of the default directory of the current buffer. It should be an absolute directory name. On GNU and Unix systems, these names start with slash and ampersand and end with slash. Not ampersand, tilde. Okay. So to interactively change the default directory, use the cd command. Ooh, that's kind of cool. So cd. Okay, so I suppose what we have to do is a default directory. So let's reevaluate, and it is in fact default directory. Okay, so its pwd is within the module called files, files.l. Can we find more interesting things in here? So something about parents, parents, get parent. Probably parent, yeah, it's probably not even file name parent directory. Return the directory name of the parent directory of the file name, and this is probably what we need in here. You know, it's kind of cool that you can like literally read majority of the source code of Emacs, right? So because majority of the commands of Emacs are written in Emacs Lisp and they're just like, you know, script files. But there are some commands that are not. Some of them are written in C and they go down into the C implementation. Okay, so let's go to here. And what I want to do is something like this. Might as well, by the way, return a list. So the first element of the list is going to be the default directory and then the parent of the default directory. Right, I'm going to reevaluate that. And here is the list. So the first element is this thing. And the second one is this thing. So we're capable of going up. We're capable of going up. So another thing that I would love to check, how does it react if I try to get the parent directory over root? This is poggers, meine Freunde. You know why? Because it makes it super easy to do this shit in a loop. So because you can have a variable, and while this variable is not nil, while it is true, you keep chopping, and then at some point you stop. Budgeting? Budgeting. Okay, so let's actually see. We're gonna have something like a dir, right? So this is the default directory. Directory, and as far as I know, there is a loops like while. Yeah, so here's like while test, and it just repeats the body until it's true. So while dir, we're gonna be doing what? We're gonna be just printing. We're gonna be printing the dir, right? So as a string, and then we're gonna set. So this is how you set a variable, right? So set each symbol to the value of its value, right? So we're setting a symbol directory to its parent. We're setting it to its parent. There we go. And we'll evaluate this entire thing. And let's just call it tasks find database. Let's evaluate that. So it was printing that to the messages. Let's take a look at the messages. Oh, that was interesting. So it printed it. So it didn't work. So that means setQ didn't actually modify this binding. Is that how it works? So that is sad. So I thought you're able to modify the LED bindings. Apparently you cannot. So let's Google that up. So Emacs Lisp setQ LED bindings. So do we have you don't change dir? That is Okay, thank you so much. It printed nil at the bottom. Okay, it printed nil at the bottom, and so what we need to do now, we need to check if a particular directory exists, right? So here's the module files where we found pwd. Is it possible to check if something exists? Okay. File exists p. Okay. So return true if file exists. Budgeting. So we take in dir, and we probably want to do something like format, right? Format, and we just do s, and we're looking for tasks. So this is the thing, and we can just say if file exists p, right? If this particular file exists p, we just return that. But what's interesting is that, is it possible to return out of the while loop? Is it even possible to return? That's an interesting question. That's an interesting question. Right, so first of all, we probably want to factor it out into something like tasks dir. Right, that's one thing we probably want to do. Tasks dir. Or just set dir to nil. Task-f. That's pretty progress. Okay, so, but does Emacs Lisp have something like break? I wonder. No, it doesn't. Huh. There's no break. So I'm gonna keep setting directory to nil as a plan B, but I'm really curious, how do you break out of the loops in Emacs Lisp? Emacs Lisp break out of loop. It's a very interesting question, actually. So Emacs, you can break through. So by throwing an don't fucking tell me that this is how you break out of loop. Chat. It's freaking OCaml overall again. OCaml break from loop. Oh my god. It's like, why they keep making these languages? Why they keep making? I understand it's a functional language. You're not supposed to use loop and stuff like that. But sometimes you end up using loop. And yeah, I can't even open. OCaml is banned, but essentially OCaml also actually suggests you to, it doesn't have break and continue statements. So instead use exceptions to exit from loops. Motherfucker. So Python does it too under the... Oh, well, I mean, at least it tries to... At least it's ashamed of that. You know what I'm saying? It is ashamed of that because it's trying to hide that behind some like keywords and stuff like that. Those motherfuckers are not even ashamed of being shit languages. That's what I'm saying. Like, I understand Python, right? So, okay, at least you are ashamed of that. So it said something about return. Maybe what said something about return? I kind of missed that. By using return clause. But I mean, it's for the CL loop. It's for a different kind of loop that we don't use in here. Python is probably slow. Yeah, it's kind of interesting how Python is sort of like self-aware that it's shit. You know what I'm saying? there's some level of self-awareness about Python. Like, yeah, it knows I'm shit, but I provide useful libraries. What you gonna do? Yes, I'm slow. Yes, I'm shit. Let's all of that. Yeah. But look how many batteries I have. What you gonna do? Move to other languages then. And it's like they don't care. There's something kind of endearing about like this Python attitude. Like it knows that it's shit, but it doesn't care because it knows that it hook you up in all of these good libraries. It knows. Like, oh, it's too slow. Use NumPy. Anyways. So commonplace in Python that it provides workarounds for its shitness. True. Yeah, so it's just like it's shit, but it always provides you something. You can always kind of just like hack it up. So, yes. What we're gonna do? So here's the task dir, right? So here's the task dir. So this is that. We're already inside of it. And when, right? So when it exists, right? When it exists, what we want to do, we want to set this to true and then return the task dir. Instantly returning out of that is probably not going to be easy. So which means that maybe what I should do is have a task dir somewhere here, right? So as new, so I'm just setting it in here. And what I'm doing effectively is just maybe simply set q. I kind of realized that this is a very stupid way of doing that, right? I do realize that. Right, and when it exists, right, when we like confirm that it exists, the dir has to be set to nil, right? The dir has to be set to nil, and otherwise it has to be set to something else, which actually gives me an interesting idea, right? So you can just use something like if. You can always do something like this. If it exists, we set dir to nil. Otherwise, we set dir to file. So what was the file name parent directory, right? So it was a file name parent directory. You set it like that. But you know what's funny is that Lisp allows you to invert this if. You can do this shit the other way around. You can set it like that, and then you can put if instead of nil, and in here, this is your nil argument, otherwise it's that argument. You see? Because if is also an expression, you can do shit like that in Lisp. Is it readable even? Like, I'm not quite sure. So, it's kind of funny. It's not a bad code. More readable than before, probably. Yeah. Looks like ternary. Yeah, because ternary priority is just an if as expression, but any if in Lisp is an expression, so it's totally fine. For example, you can probably do the same thing in Rust, right? So because in Rust, if is also an expression, so you can always just probably do some shit Rust mode. You have a variable x, and then if some condition, right? So some condition, you return 69, otherwise you return 420. So it's kind of the same logic. It's kind of the same logic. Never using Lisp in my life. Sometimes you have no choice, right? Sometimes you have no choice. Sometimes you have to write software for some system that you don't control, and yeah. That led me to using all sorts of languages that I actually don't want to use, but I use them anyway. Okay, and we forgot to return this thing. So tasks dir, we have to just return it like this. So the last argument in the expression is what the entire expression returns. So that's what it is. All right. We found the tasks. So, but this is like, there's a little bit of problem with the slash, right? So there is an extra, oh, this is weird. Why did it return this shit? It's supposed to return task, but yeah. So file exists. How is that even possible? So here is the current dir. I add the tasks. Right, then if this thing exists, I just set it to new, or I set it to the next one, and the cycle continues. So how would it end up like this? I don't get it. I don't see how it would end up like this, honestly, chat. I just don't see it. So this is that. Ah, that's kind of funny. That is kind of funny. So, but this doesn't exist. Ah, this path does exist, chat. This path does exist. It's just the tasks isn't executable. Fuck me. Like, this is so fucking funny. Okay, so like I'm already. So here's the thing. I'm already inside of tasks folder. So what it did, it just appended tasks and asked, does it exist? Yes, it does exist, so it returned it. So the algorithm works correctly. The algorithm works absolutely correctly. Is dir? I have no idea. So is directory. At least it is not called isdir. So we have to check is directory. Wait. Okay, so maybe it's something local. If not is directory. Ah, it's a binding. Okay, so file directory p. Okay. So, and what we can do in here is that we can do a condition. In Lisp, you can do and condition 1, condition 2, condition 3, and so on and so forth. So this is how and works in here. And one of the things we can do, we can just add additional and in here. File exists and file directory, task dir. So this is what we can do. But maybe only file directory is enough, right? Because if it's missing, okay, so return true if file name names an existing directory. I feel like this could be redundant, actually. Checking for existence could be redundant if you already check for is directory. We can do something like this. Let's put something that doesn't exist, right? So aboba, and it just returns nil, right? So it doesn't throw any exceptions or anything, so it is redundant. It checks for existence and the fact that it is directory. Okay, so that's kind of perfect. All right, and it works. Yeah, it works. So what about this double slash? One thing to get rid of this double slash is probably to normalize path, right? You know, the path normalization and stuff like that. But do we have anything like normalize path? There's nothing like that. Okay, so maybe it's something in files, normalize DOS-ish file names. System type, Windows NT, MS-DOS, Cygwin. So in Emacs list, in Emacs code, there is still some code that checks whether you're running inside of MS-DOS. Speaking of how old Emacs is, it's from 85, right? 1985. There's still some code that assumes that you might be running in MS-DOS. Yeah. So normalizing, maybe there's, okay, so there's the only place that normalizes the stuff. So maybe there's some functions that let you construct paths. So anything about path? Or maybe a concat path? Concat path. Nothing like that. So just format if it always ends with slash. Yes. That's very important. If it always ends with slash. But does it? That's the main question. How can you guarantee that? So, all right, let me see. Let's take a look at the variable definition of default directory. So, name of default directory in the current buffer, it should be an absolute name. So this name start with slash or and end with. Okay. So we know for sure default directory always ends with slash. So does file name parent directory always guarantee that it's going to end with slash? So return the directory name of the parent directory. Is not the root, blah, blah, blah. The documentation doesn't say anything about them ending with slash. So there is a file path join. Okay, so file path join. I didn't see that. It's path join. This. You just hallucinated that. Are you guys just hallucinating random? Oh, question mark. Okay, I'm sorry. Okay. Guessing. But I mean, the question mark doesn't mean that it doesn't exist. It might mean, what about using this function? Right, so question mark doesn't really, you know, reduce the ambiguity. All right, so let's actually Google Emacs Lisp join file paths. Let's take a look at the Google. As far as I know, concat just concatenates the strings. Concat. All right. So declare. Okay, sequences, concatenate all the sequences and make the result string. Blah blah blah. So let me see. File name concat. Okay, I'm gonna sneeze, by the way, chat. Chat, I'm gonna fucking sneeze. I'm gonna Djibouti. So directory components. Okay. File name concat. So file name concat is gonna be dir and tasks. Okay. So that should be it. So let's try to do this thing. And it's perfect. It is perfect. Absolutely perfect. Now, so let me make it interactive. Actually, I don't really have to make it interactive. So I'm gonna go to the place where I don't have tasks, right? So I'm currently gonna be outside of the repo where there's tasks. So that means this entire thing should go up until the root and return nothing eventually. So I want to test for that. So I'm gonna evaluate expression, right? So I'm evaluating expression, and the expression is gonna be just call this function. Wait a second. Okay, so this was weird because it returned me tasks. That doesn't make any fucking sense, my friend. All right. So if this is, yeah, so task, and if task directory and it exists, you return. Honestly, if you kind of reached nil, yeah, I always said dir. Yeah, I know that. It's kind of annoying. You know, like short-circuiting the whole thing. Short-circuiting the whole thing would have been much easier, right? So then dealing with all of this shit. But this is what it is, and this is what it isn't. Let me just quickly pour some water. So we need to come up with a different strategy than relying on this kind of stuff. So my problem is that doing something else requires too many things in a then branch, and then branch in if of Lisp is limited to only one action. So that's how if else works in Lisp. So the first one is the if keyword, then the condition, then one single item for then, and shit ton of things for else. It's kind of weird. I really don't like that, and I never understood that. But yeah, we'll see. I want to pour some water, and we're gonna try to come up with something better. Super quick, super quick. All right, what would be the better solution? What would be the better solution? Okay, so let's get rid of that. Let's go back to maybe let. So this is the pair, and this is the list of pairs of all of these things. So we just do something like that. So we create this temporary thing, and the first important stuff in here is that if it exists, we just want to return the whole function. Am I thinking too imperatively? Am I thinking too imperatively about this shit? I feel like that's what's going on in here. Right, while dir, we can have something like result, which is new, while dir and not result is not even a function. Yeah. So return true if object is nil. Right. Return nil otherwise. So while there's a dir and no result, we just keep doing that. If this thing exists, we just set result to task dir. Otherwise, we set dir to its parent. Interesting. So that could be a better solution. And at the end, we just return result. So that could be it, actually, but we have to do inside of this stuff. Yeah, just a second. Yeah, that's result. So why is the multi-threaded renderer marked as discarded? Because I'm not uploading it to YouTube. It's not going to perform on YouTube well. So on the parentheses, I plan to do like a separate offline session where I walk through multi-threaded renderer, right? So, but I'm not uploading that session. You can still watch session on Kick. It's going to be removed at some point, but I don't want to upload that session to YouTube. You can upload it, like I don't want to upload it. You can archive it, you can do whatever you want with it. It's just like, it's generally discarded. So it's just like a not particularly successful session. So yes, so this is the thing I want to do, right? This is the thing I want to do. And the tasks find databases. So, okay, void variable task dir, void variable task dir, task s dir. Okay. All right, and it returns everything correctly. So now let's try to do that one more time. I'm going into the place where there's no tasks folder, and I'm trying to evaluate this entire stuff, and we got nil. This is perfect. We got nil. So, okay. So we can create a new HUID. We can find the database. So we have all of the necessary components, I would say. So here's this. Okay, so here's to do. We extract prefix and suffix. So the thing we need to do in here now is probably also find the database or tasks dir. So I just kind of want to rename tasks dir to something else because maybe it's a database dir. Maybe it has to be database dir. Whatever. Because nah, it has to be renamed properly. So query replace tasks dir, database dir. dbdir. Maybe what about like calling it dbdir? Skibidir. By the way, so we recently were discussing on Discord like a pretty cool name for a database, skidb. Somebody should come up with a database and call it skidb. It's a perfect marketing for Zoomers. I'm telling you, you're sitting on a gold mine. Create a database and call it skidb. It's a freaking perfect name, skidb. So here's the prefix, suffix, and we want to do dbdir. Okay, so this is a dbdir, and we do tasks, find database, right? So finding a database, and we actually don't want to do anything if the database is not found. That's the thing. So we're gonna do when dbdir is available, only then we're gonna try to do something. I'm gonna try to do something. When the dbdir is available, we need to generate a new HUID. So this is gonna be HUID, tasks, new HUID, and I'm gonna put it in here. So this is a prefix. Is it a good idea to... Yeah, I think it is. I think it is. Match line. I feel like there's a little bit of a weird state in match string. Notice how I apply the regular expression to the string, and then to get a captcha group out of that string, I provide this string back. What if somebody inside of this function calls does a string match with a different regular expression on the same string? So then in here, I try to query it, and I will actually query a completely non-existent thing. So it feels like match string and string match are utilizing some sort of a global state, and I feel like it may like backfire. I have a feeling that it may backfire. So I think you should not call match string if you do something else. You see what I'm saying? You see what I'm saying? I think it's kind of weird. So probably want to do something like let in here. Oh, and by the way, something that I forgot to mention. As far as I know, the order of execution of this binding cell in let is not defined, if I remember correctly. So you can do some interesting shit. For example, so here's A, which is 69, and then you can say, okay, A is B, and you can try to maybe print both of them. So A and B. If you try to evaluate that, it says void variable B. I'm an idiot. BA. I'm sorry. But it still says void variable A. So you can't define other bindings in terms of another bindings. So the order is kind of like not defined. And if you want the order to be defined, you put star in here, and only then it just allows you to do that. We can take a look at the definition of this function. So bind variable according to var list, then eval body, the value of the last form body, blah, blah, blah. I mean, okay, so each value form can refer to the symbols already bound by the var list, but it doesn't tell you exact order of execution of these things. So, and because of that, I'm a little bit, worried that something may fuck up at some point. So because of that, I feel like I want to actually put that into a separate let binding, just in case. You know what I'm saying? It's just like, we did a match, it was successful, so we instantly got prefix and suffix, we just save them. Then we try to find the database, right, and we check if it was successful or not. And then we continue with all of these things. So we find in the HUID, right, so we find in the HUID, we probably want to also construct the task path. In here, file name concat, we provide the dbdir, skibdir, and HUID. So here's the task path. So one thing we have to check whether task path already exists. Right, so we kind of have to, is there something like assert? There is, look at that. So this function is a, okay. Oh, it's a from common list. cl.el is actually rather interesting thing. It's a compatibility aliases for CL library, and CL stands for Common Lisp. Remember how I said that Emacs Lisp is trying to kind of mimic or role play Common Lisp? They even have a Common Lisp compatibility layer. They want you to be Common Lisp so badly that they even had like a layer for that. I don't really know why. So eLisp let quirks. I don't think it is eLisp thing. I think lets in Lisps are generally quirky. So this Emacs Lisp let is not that different from let in Common Lisp, and it's not that different from let in schemas. Right, so I wouldn't blame Emacs Lisp specifically. So it's just like Lisps in general. This is how their lets work. They're kind of quirky. And as far as I know, lets can be implemented in terms of lambdas, if that makes any sense. You know what I'm saying? I remember, I think in SITSP, Structure Interpretation of Computer Programs, they demonstrated how just like applying a lambda is basically implementing your own let. So imagine that you have a lambda. Maybe I'm gonna do Lisp mode of some sort. Maybe not. Can I do schema mode? Yeah, schema mode. So here's the lambda. It accepts A, right? And then it like uses A, right? You call some function with an A, but what you do, you call the lambda with a value 69, and this thing is equivalent of let A 69 uses A. And from what I can remember in structure interpretation computer programs, right? So let's actually find CISP because it's an open book, anybody can read it. So they even suggested to just implement a macro that just expands this kind of thing to this one, but I don't remember the details, right? So don't quote me on that. I remember them talking about this, that this is kind of equivalent to this kind of thing. But anyway, whatever. So what I want to do, essentially, what if task path already exists? What is task path already exists? We can, yeah, by the way, just a second, I have a readme, which explains HUID. Each folder is a task. The folder name is the task ID. The task ID is format. I already described it. Just grab the current date and time and use it as a task ID. If your task ID collides with existing one, just wait 1 second and try again. Yeah, exactly. You're right. Just wait 1 second. We can try to do that. Is there something like sleep? Sleep for... Okay. So there is a sleep in Emacs apparently. So sleep for 1 second. Okay. All right, that's interesting. So if I sleep for 5 seconds, it blocks the UI. Just saying, it blocks the UI for 5 seconds. Okay. That's very interesting. So I feel like it is very easy to shoot yourself in the leg, in a sense that if you have a different time zone than somebody else who's also created an issue, you may end up in a situation that you tried HUID, it's taken, you try another one, it's taken, and you can wait for a very long time like that. Right, so if your time zone is slightly offset than somebody else's time zone, you can end up with these ranges of IDs that are already taken because the time zone is not. So because of that, the definition of HUID must include the time zone. Emacs DDoS attack vector, yeah, exactly. Denial of HUID. It is a kind of a denial of HUID. So because of that, I don't want to sleep, right? So because it's very easy to just like end up in this kind of situation. I feel like what needs to be done in here is just like crash and tell the user that it's already taken, just wait 1 second. And if there is the situation where you may get stuck, at least you have control back to the editor and you can do something about that. So yeah, so I think sleeping is a bad idea. So we're not going to be sleeping in here. But we need to throw some sort of an error. So if file, not even file exists p, right? When file exists p, right? So when file exists p, task path. I feel like we have to throw an exception. Is there something? Okay, so there is a throw, and how do you even use that? Throw to catch for tag. I have no idea what is a tag, and return value from it. Probably introduced at or before Emacs 13. Yeah, I remember that. So for some of the functions, Emacs developers themselves don't even know when things were introduced. So, and because of that, they're worded in this particular way. It would be kind of nice to know what exactly all of that means, because I don't quite understand. And by the way, this is a C function, so it's not written in Emacs Lisp, and you can't even get the source code. So the thing about this link is that if you build Emacs from the source code, this link becomes active and it will actually literally jump to the original source code of Emacs from which you build this entire thing from. So you can also inspect some of the C functions of Emacs, which is kind of useful. So, but here I installed it from the repo of Void, so I can't actually explore that. Okay. So yeah, I need a little bit more explanation. Emacs Lisp throw, because this is not particularly useful. Throw to catch for tag and return value from it. What the fuck does that mean? Catch and throw. Let's read some documentation. So explicit non-local exits. So there is a way to exit earlier. It's catch through, but it's not really exception. It's kind of weird. I don't really understand. Most control constructs affect only the flow of control within construct itself. The function throw is the exception to this rule of normal program execution. It performs a non-local exit on request. Exit from what? From a function or what exactly? There are other exceptions, and the word exception in here is actually used very liberally. So do they mean exception as in Java exception or exception from the rule? It's really weird. But there are error handling only. Throw is used inside a catch and jumps back to that catch. I see. So you need to first wrap it in a catch. So you throw a particular tag and you catch a particular tag. And true, and not really sure what exactly this returns, but let's take a look at catch. So does intention matter in Emacs Lisp? No. So eval body allowing non-local exits using throw. We already got that. Tag is evaluated to get the tag to use. It must not be nil. Yeah, so does that mean I can then use this value foo somehow? Then the body is executed within body. A call to throw with the same tag exits body and this catch. So you can also apply one single tag, right? You can only catch one single tag with a single catch construction. If no throw happens, catch returns the value of the last body form. If a throw happens, it specifies the value to return from catch. Ooh, I see. Let me actually see. So can we just have something like define foo, right? And then here I'm gonna just throw your mom 69. Okay, so if I call this function, it throws an exception. It even gives you the call stack and so on and so forth, and it just tells me that your mom 69 was never catched. Okay, that's very interesting. So if I do catch foo, right? If I do catch foo. Okay, no catch your mom. I'm an idiot. So I have to say your mom. All right. And look at that. It returns 69. That is very interesting. This value tells Emacs runtime what value this entire expression must return. So that's what's going on in here. But if you don't throw and just return 420, it will return 420. Well, I need to reevaluate that. It will return 420, right? So that way I return 420. Here's 420. And if I throw, I return 69. It's kind of an interesting system. Kind of like that. So this is what non-local throw means. And I think I understand how I could have actually exited from here. Wait. What if... Okay, let's get rid of the result. There's no result in here. So which means that this is not a thing, this is not a thing. Okay. So if this file exists, what I can do, I can throw result like that. Okay. So after that, I can just say catch result. I personally never used throw and catch, but I feel like this could be a very good solution because it's non-local. So if it will throw, it will basically return this value from this entire construct. Yo, this is very convenient. Is throw and catch the same in Common Lisp, or is that a purely Emacs Lisp thing? You can throw your mom in several places with different values. I think you can. Right, I think it could be the case. So let me think. It's just like anywhere from the call stack, right? So you do catch, and you perform, you know, foo call, and foo may go in all of the places. It traverses the call tree, right? It traverses in the call tree, and anywhere in that call tree, it may do throw your mom, and that will start unwinding the call tree until there's a catch your mom. And as soon as you catch your mom, it will return that value that you set down there in the call stack. So it is kind of exceptions in Java, right? Except it's just like you literally return this thing. So commonly used has throw catch is very calculated, but I'm not sure how similar it is to Emacs. Yeah, I'm also not sure, since I've never used it. But this mechanism is actually seems pretty simple, and I feel like it's actually perfect for this case. I'm not sure if it's too slow, right? But tasks find database. I can just call this in, and it works. Look at that. So I reevaluate it one more time. So short circuiting through and catch works fine, even though it's kind of weird, right? So, but it works fine. What I like about it is that there's no special exception value. What this exception mechanism does, it just says what that outer catch must return. Deep from within the catch, I can say this entire catch now returns this value, which is insanely convenient in my opinion. Right. So it's not even exception mechanism. It's just like it's a like non-local. Yeah, exactly. They say it's a non-local return or whatever. Just a return. So it's basically FP go. That's a very interesting way to look at it. It's basically an FP go to. Yeah. I learned something. I didn't expect to learn something on the freaking Emacs Lisp stream, but yeah, there we go. Okay. So, and we can try to call that in a place where we don't have a val expression, the task, and it returns new. It's literally equivalent to what I wrote before. Okay, I'm super happy about this thing. All right, so what we're doing, we want to task create. So if it was not found, I might as well just throw some sort of, maybe do a message. All right, so if exists, more like if exists, I'm gonna just say message, right, error, this already exists, try again later, this is a horrible user experience, honestly, but maybe I can fix that a little bit later. Right. So if it exists, we just say this message and this entire expression will exit. If it doesn't exist, we go inside of the else and we delete the line, insert the line. But the first thing I feel like we have to do, we have to create a folder. Do we have something like make dir? Okay, so there is literally make dir. Let's create a dir. So it's going to be task path. We just created the dir. Within that dir, I need to create a file. So it's basically a package for parsing all the files in the project looking for tasks I just got here. It's basically, yeah, it's basically extension for creating and working with these tasks in this folder. So as of right now, we're implementing very limited functionality, which is an ability to stand on this to-do and say something like, create a task from this to-do. So what it's supposed to do, it's supposed to find a task folder, create a HUID, which is a human unique identifier, and just like, you know, initialize with this title and so on and so forth. That's kind of the idea. So let's freaking go. How do you create a freaking file in Emacs? Okay. Essentially, you can open files, right? You can open files. I remember that there was a way to kind of open a file, then insert something into it and close it, but all of that without the user seeing. There was a very interesting macro called save excursion. Maybe this is what we want. Save the point in the current buffer, execute. To open a file, you find the file, right? So that's the function that you usually call, right? Find file. So alternative to native comp function, it keys are remapped, but where is the description? Edit file, file name. Switch to a buffer, visiting file name, creating one if none already exists. This is one thing we can try to do. So this is a task path. We need to file name concat task path, and I want to create task md. So that's the path we're dealing with. Then we're trying to find file. We're finding the file. Does it return anything? Interact with the default if you just type enter. Yeah, so we can just do shell command touch file. That's true. File name at point. So you can also do some other things. So it integrates with tramp. So maybe it's too high level for what I'm trying to do. Okay, let me Google Emacs Lisp create file with content. So there should be some sort of like a low level way to do that. Write file. Sadi. Yo, what's up? Thank you so much. Write region. So write region or string to a file. Yeah. This is the Emacs legend, by the way. This is the Emacs legend. Is that what I want? I feel like this is what I want. So let me see. Write region or write file. So file name. Append to file. Save buffer. Write temporary file. What would be the better strategy, honestly? What would be the better strategy? Emacs, maybe write string to a file. Because what I want, I just want to create. Write region also accepts a string. Because the region is usually 2 points. Start. Yeah, usually 2 points, like where the region starts and where the region ends. But apparently, if start is a string, then output that string to. Nice API, Richard Stallman. Of course, start in a write region can be a string, of course. Instead of creating something like write string, which has its own interface and stuff like that, let's actually hack write region. Nice API. Very intuitive, very fucking intuitive. Yeah. So the end can also be nil, right? So I swear to God, why people do that? Polymorphism, yeah, exactly, polymorphism. Right region. Right region start, and I can just create. I have a prefix, by the way. This is the prefix, so I can say, let's say format, and this is going to be title, not title, but S with a new line, and this is the prefix that we're writing. So this one is new. And then the file name, and the file name is this thing. So that's the file name we're writing. Okay, so that's pretty cool. So we wrote that to the file, then we deleted the line, and then we inserted this line in here. After that, I want to kind of open this file in a separate buffer. So find the file. Does it accept some sort of a parameter to open in a separate buffer? I think it does not. So is there some functions like visit file? So Emacs Lisp open file in a separate. I think it's called window. These separate frames are actually called windows. Yeah. In a separate window. There should be a way to like open a file. How to make Emacs open? This is not what I want. Find file along with display buffer. For example, To open a file in a separate window in Emacs, you can use command find file along with display buffer. For example, you can call display buffer find file. What the fuck is a display buffer? Excuse me. Display buffer or name in some window. So find, so there is a variant of find file, non-select. It's not even, there's no such function, Brovsky. Did I get clanked on? I feel like I just got clanked on. So because there's no, oh no, there is, okay. So read file into buffer and return the buffer. If buffer exists, visiting, okay. I feel like this is what we can do instead. So there's also find file other window. Okay, find file other window, not frame, but other window. Okay, that's cool. Does it return the buffer? Return. It should return something. Because if it returns the buffer, then we can try to maybe insert something into that buffer programmatically, but that's besides the point. So let's actually make something work first, and then we can try to optimize that. So, all right. What I need to do is just do this kind of thing. Thank you so much, Bitstream. Let me maybe factor it out. So we have task md path. Let's introduce that. Let task md path. So this is that. And let's put all of that stuff. Task md path. So what I'm thinking, maybe the first thing we have to do is delete the current line and insert a new variant of that line. Then create the folder, corresponding folder, write region into that file, write region into that file, and only then open that file. And I feel like writing something into the file and opening the file can be then merged together into a single operation where I'm just opening that file if it doesn't exist, visit it, and then inserting something in there. I feel like it could be feasible. Because of that, look, taskmd is only used down there, which means that it probably makes sense to move these separations up there, right? So because this file path is only needed for these two operations. Look at this beautiful language. Do you like Lisp? This is the language of God. It's a divine language that everybody is telling you about. Look how beautiful it is. Look how beautiful it is, isn't it? It's absolute budgeting moment. So I'm pretty sure this is not going to even work first try. And because this language is so dynamic, you can't catch errors at compile time or at evaluation time. Right, so there could be some sort of an error in here, and you will never know. Well, you will know, it's just like it's gonna tell you a very annoying message. Go into speech therapist after this tree. Okay, you're welcome. Let's try to create a fucking task out of this mother flipper. Are you guys ready? Create from to do. It worked. It unironically worked. It's just like instead of inserting suffix, I inserted prefix. So here it is. Absolute budgeting. Dub. So right. And here it is. It created a new thing. It's the same ID. Right, it's the same ID. And we can even take a look at the git diff. Okay, and here it is. It literally created a new folder. So let me remove that shit. Let me remove that shit. And let me remove that shit. So let's go back to task. So where is the prefix? So this is a prefix, yeah. So here is the bug. Suffix. Should have used suffix. Okay, so now I'm going back to here. And here's the to-do. I want to create a task out of to-do. Creating a task out of to-do is annoying because you have to navigate to the tasks folder, right? Then copy paste this title, then go and it's just like task new, then reconnecting it back to this. It's very fucking annoying. Now, I just create. I just, here is the to-do, MD, stuff like that. So, and it connected it correctly. So it automated a lot of shit that is very annoying to do. So now if I like look at to-do and I see, okay, so this is task worthy. It makes it super easy for me to actually, you know, turn it into a task. So now following HUID for file. Yeah, so that would be actually kind of cool. So there is still a bunch of bugs that we need to fix in here. First of all, we need to trim the titles. As you can see, there is an extra space in here. There's an extra space. On top of that, this is not a full file, full task.md file. Oh yeah, so there is a with temporary buffer macro. But in our case, we don't work with the temporary buffer, we're working with existing buffer. So maybe also add default params status open priority. We might do that. We can even add some interactive parameters in here, right? So here it's interactive, right? So we can make it prompt. Is it going to have certain tags? What's the priority? And we can just generate all of that stuff. So there's a lot of room for improvement. And it's kind of cool how we just, like, before starting the stream, I literally didn't know how to do any of that. Like, I didn't know how exactly I'm gonna even fucking approach that. So, but just by exploring things, we pieced all of that stuff together. And it's kind of fun, right? So making extensions for Emacs is kind of fun like that. That's why people like it, right? So debugging all of that shit is not fun, honestly. I personally believe that Emacs, not Emacs, but Lisp in general, is kind of a write-only language. You know what I mean? It is very fun to write, but when it comes to debugging the shit, like, you don't want to touch it. Like, I do not want to touch it. Though, maybe there are very powerful tools for debugging Lisp, like, for example, Slime. It's a like IDE for common Lisp that integrates with Emacs and stuff like that, so they kind of help you to debug all of that stuff, but it's just like you generally don't want to touch it. Yeah, like APL enforced, exactly, it's kind of similar in that. So it's just like write only. It's very fun to write, insanely fun to write, but reading and debugging, no, I don't want to touch that. Write once, debug everywhere. I hate debugging this. I have a feeling that maybe we just like don't know how to properly do that. Right, if you have powerful tools, maybe it is also fun. Right. So there's a thing called Emacs Slime. All right, and if people say like if you learn how to use this superior Lisp interaction mode for Emacs, if you learn how to use this, it just like makes it super easy. It's not that bad if you have a good reply. Yeah, exactly. So, but anyways, yeah, we need to trim. So is there something like a string trim? Strip. Okay. Emacs Lisp trim string. Okay. Oh, there is literally string trim. Oh, yeah. Trim left, trim right. Trim left and trim right are literally expressions, regular expressions. Let me test it. String trim. Hello world. Okay, it trims them from the both ends. So what that means is that, honestly, what I want to do is probably trim the whole thing like that. So we get the group and we trim it from both of the ends right away, which will also affect what we're inserting into the current buffer too. Yeah. Okay, so what's the best way to kind of define a big string in here? What's the best way? Maybe something like concat, right? So we're concatenating all of this stuff. Not really sure what the fuck is going on here, why it is red, but okay. So format. So this is going to be a new line, and in here, what I want to do. So let's take a look at some of the existing tasks in here. So there should be status. Original is going to be open. So the next one is priority. Priority, let's say it's going to be 30, or maybe even 50. Why trim? Oh yeah, not prefix. Thank you so much. It's just trim string trim. Let's go. So this is gonna be that, and yeah, I guess that's it for now. I think the reason why Lisp may be hard to debug is that it's very dense and all the values are just passes around without sorting them in any local variables or something. Yeah, that's true. I think this is the kind of criticism that John has towards not only Lisp but functional programming in general, is that they pack the useful information too densely to the point that it's very difficult to work with that information. Which surprisingly I kind of agree with, to be honest. Right, so I kind of agree with that take. Okay, so I fixed all of this stuff. Can we just try to do that? Not bad. Not bad at all. So there is another bug in here, is that I trimmed the suffix, but now I have to add artificial space in here. Okay, so let me try to do that one more time. So there's a root C. It's kind of weird. It's not in modifications. Okay. So we created a bunch of things in here. We don't need them anymore. So where is that? So here is the space that we need to create. Seems now the title is completely trimmed. There should be like space in here. Okay, now the last test. And we're going to try to create the whole thing. Here is the task. Here it is connected. That is perfect. Absolute budgeting moment. Absolute budgeting. So the way we create a new file is not ideal, in my opinion. It is not ideal, but I feel like trying to improve it, and I don't even know what's going to be improvement, is just going to be a waste of time for now. I'm going to leave it as it is and just move on because it works for now. Whatever I'm doing in here works for now, so that's totally fine. So the next would be to maybe go to a particular task by HUID. That's probably one thing we can do. So ideally, I would like to be able to just click on this thing. So there should be some sort of a minor mode that identifies HUID and just creates a links out of them the way, for example, debug mode, not debug mode, but compilation mode creates links. You can try to compile the project. Can I just compile? Nope. Yeah, so as you can see, it identifies some of the patterns in the log and turns them into links, and it triggers some code when you click on those links. It would be kind of cool to have some sort of a minor mode working in the background that detects these kind of things, turns them into links, and when you click them, or maybe just stand on them with the cursor and do a shortcut, it jumps into the corresponding file. That would have been ideal. So it's kind of similar to fly check, right? So which checks for compilation errors and just highlights them within this kind of thing. But that is a rather long way to go. The file created is saved, yeah. So it's first saved and then it's opened. So it's totally fine. I think the first step in implementing something like that would be to have some sort of a function, tasks find by HUID. And it's going to be an interactive function that asks for HUID. And once you've got a HUID, it looks for it in a tasks database and just opens it up. Right, so this is the first piece puzzle in this entire thing. As soon as you have that function, you can work separately on just turning text into links and then identify and click on the links and stuff like that. And you only need to call that function that you already have, right? So, yeah. Funnily enough, we already have necessary mechanisms to make it work, because what does it mean? It means like you have to take the ID, the HUID ID, find the tasks database, concatenate it, check that the file task.md file there exists, and if it exists, open it. It's very easy to implement already because we already did all of the heavy lifting while we were implementing create, from to do. So let's create a function. So tasks. Find by HUID, and here we're going to be accepting le HUID, And it's supposed to be interactive. So the thing is, there's some functions in Emacs that are interactive. So that means you can call them in MX, you call them and they prompt you for, for the input. So we can take a look at how compile is defined, for instance. And what's interesting is that what they're prompting you for is also an argument. But if you just create this kind of thing with an argument, it's not going to prompt you for that argument. So if I just create this function and I'm calling tasks find by HUID, it didn't prompt me, and furthermore, it said you didn't provide the argument. So the way you have to code this entire thing, you have to add additional parameters to the interactive thing in here. And it is weird. It is absolutely weird. So here's the implementation of compile. So first thing is documentation, right? So by the way, Python stole this idea from Lisp, right? Lisp was the first one to use these kind of strings for documentation purposes. Yeah, so you have to provide these additional commands, and I have no idea how that works. So Bitstream, do you know how to work with interactive thing? Because every time I do, I just kind of have to learn it from scratch, and it's weird, it's bizarre, and it's like, who the fuck designed this entire thing? Like, I do not understand it. So let's take a look at interactive. Okay, so look, all of the parameters here are optional, first of all, and there is a so-called arg descriptor. Okay, so what's the documentation? Specify a way of parsing arguments for interactive use of a function. For example, write, docstring interactive p new line b buffer : to make arg to be a row prefix argument and set buff, which is I suppose the buff, to an existing buffer when full. How the fuck does that make any sense? Interact is a way to provide arguments to mu before calling a function. Yeah, but it's like, why it is designed this way? Like, what? The call to interactive is actually a declaration rather than a function. Yeah, so it's kind of like a magical in a sense. It tells call interactively how to read arguments to pass the function when actually called. Interactive just returns nil. Understandable. Usually the arguments of interactive is a string containing a code letter followed optionally by a prompt. Some code letters do not use IO to get the arguments and do not use prompts. To pass several arguments to the command, concatenate the individual strings, separating them with new lines characters. I suppose that's what this new line means? So string describes code letters that tells you how to read parameters, and each parameter is separated by a new line. Yeah, so you can use a completing read, and this is not exactly what I want. I want to use the mechanism, the usual mechanism of Emacs. All right. So prompts are passed to format and may use %s escapes to print the arguments that have already been read. I have no idea how this is related to what I'm trying to do, but anyway. If the argument is not a string, it is evaluated to get a list of arguments to pass as the command. Okay, so that's why in the implementation of compile, interactive was not a string, but rather a list. Okay, so just interactive means pass no argument to the command when called interactively. Code letters available are, okay, so a function name. Name of an existing buffer. If it's a B, it's a name of the existing buffer. Capital B, name of a buffer possibly non-existing. Do you have a strings? I suspect if you want to read just a string, it could be just S, any string. Okay, so this is a code, and okay, I have a feeling that for me to make it interactively read HUID as a string, the only thing I have to provide in here is S, and maybe that will work. So let's actually put HUID in here. And I'm going to try to run it. It's waiting for something. I guess it's not that scary, right? So for each argument, you just provide a code. So string is a list of codes. So we can say something like HUID. So, and this is going to be used as a prompt. So let's evaluate this thing. Tasks find by who. Okay, look at that. Look at this is the prompt. It is asking me for a prompt, your mama, and then it printed your mama back. Okay, that was easier than expected, honestly. And then if you have several arguments, HUID another. So let's say arg. I suppose I can just say a new line, and where's the interactive? Not really man, but interactive. Where are the codes? What about a number? Okay, so value of point as number does not do IO. Okay, number read using mini buffer. Okay, that's pretty cool. So that means I can say that this is a number, and let's print both of them. There's going to be message s, maybe HUID that, arg that, HUID arg. So doing it like that, let's evaluate that. Task find by HUID, your mama, 69. All right. But it's still weird. So I understand how to use it. So it's a string. First comes the code of the type of the argument that you want, right? Then the prompt, then new line for the next argument, and then again type, the code, and then the prompt, right? So here I didn't provide any prompt, but I suppose this is how we do that. So if I just create your mama 69, as you can see, here is the arg, here's the arg, I put 69, and there we go. So that's how we do that. But still, it's kind of weird. So another thing, so here's your mama, but then I'm gonna provide string where it expects a number, and it's gonna say, it said please enter number. Look down there. Please enter number, and it asks again. So it provides a little bit of like a type safety, right? So it checks if the user tries to put something that is not expected. So this is what it's used for. And this is how you craft this sort of like prompts and description and stuff like that. Weird, again, but whatever. Emacs is weird generally. We got a HUID. So the first thing we have to do, we have to ask for the location of the database. The location of the database. Task find the database. Right, so task find the database, and let's do let dbdir, skibidir, and let's put this stuff in here, skibidir. And if it is available, right, dbdir, if it is available, we're going to file name concat. We're concatenating skibidir with le HUID. So here is that. And I suppose another thing I can do is just like a task md, and yeah, find file other window. Yeah, can you just autocomplete? Yeah, so this is what we can do. Okay, so that's the easiest way to go about it. Let's re-evaluate that, and I'm gonna go into the root. Then I can select it, tasks find by HUID. Absolute badgering. So for now, we can just do that. Yeah, that's one way to do that. So if you provide something that doesn't even fucking exist, so how is it going to go? Tasks by HUID, your mama. All right, so it literally created a folder. Yeah, so so your mama does not exist, create. Let's not do that. Yeah, so we have to check for that. So we have to have a little bit more checks than this. Let's maybe factor out this entire thing into like a task md path. Task md path. Like this, and there we go. So one thing we can check, does it even exist when So there is a file directory. It checks whether file exists and that file is a directory. Is there something like a file regular? Let's find out. File regular. Yeah, because what's the opposite of directory? A normal file on Unix is usually called a regular file. So knowing this convention actually helped me to find the name of the function. Yeah. So when this thing is regular, right, so when the task MD is irregular and not something else, only then we try to open it. So here's the thing. If you can't find the database, it will silently quit. If the taskmd file is not a regular file, it will silently quit. Would it be better to actually provide some sort of a message? So maybe we can do something like this. If this thing not found, we can say a message, you know, tasks database is not was not found, and just exit in here. So again, in if, first element is a condition, second element is then, and the rest of the arguments are else. And I'm starting to suspect why, because it allows you to write sort of like short-circuity code like this. Very short-circuity code. Short-circuity code. I wonder if you can use throw catch in here to make it a little bit more, like less nested. Right, so if this thing is not a regular file, we can do message task was not found. We can even do something like this, which is a HUID. How can you use throw catch in here? How can you use a throw catch? I feel like we can do message. Nah, it's gonna be a little bit annoying. So this thing probably should return the message, right? It should throw. Let's call it message. Right, throw message. And then when this happens, we should circuit like that. Then inside of this thing, when this happens, we should circuit like that. So as you can see, we're reducing the nestiness in some sense. We're reducing the nestiness. And then how are we going to exit? So we can try to catch the message in here. So that means that message will be the value of this entire thing. So if this entire thing exits successfully, it should return nil. So we have to now assign that message to some sort of a variable, check if the variable nil or not nil, and then print. So it makes it even less readable. So I don't think trying to unnest it using throw catches is not going to help the case. So in this specific case, it's better to do it like that. All right, so we got something like this. And if I try to go to here and I just do a boba. So wrong number argument throw. Did I not oh yeah, I did a fucky wacky chat. So it was trying to do the message, but then it couldn't. All right, so let me go back to here and I'm gonna just try to and task was not found, which is understandable. Abobus, yes. So let's put it like that. Task database, tasks database was not found. All right, so this is already kind of useful, even though it does not integrate with fancy stuff, which allows you to quickly jump to things. I think you already can do some stuff. We can do a pretty cool thing, is that don't ask for ID if it's a region. Don't ask for ID if it's a region. So essentially, I just select it, find by HUID, and it jumps there instantaneously. We can try to do something like that. Extend think at point. Is it extendable though? Think at point. I feel like it just provides whatever. Does it accept regular expressions? Symbol, number. Yeah, I'm not really sure how exactly to use it, but it has UUID. Why doesn't it have HUID? And think at point. Return think at point, and if it's a UUID, Things that point to URI schemes. Okay. Where is UUID? I don't see UUID. Maybe it is extendable. Like, I need to learn how to use it, so I don't really want to go in there as of right now. So speaking of selection, I do remember that I implemented at some point a functionality that allows you to search for certain things. Yeah. So essentially, I implemented a function that, given a selection, just calls find with grep to grep in the entirety of like subfolder or whatever. So I don't remember how the function is called. So let me take a look at the bindings. It was... I think it was Control X, P, S. Yeah, rgrep selected. So let's go there. It is defined in my configuration. And I used... Yeah. So the thing about interactive is that I learn how to use it only once, right? And then I forget about it. So in interactive here, we'll literally use this thing. So it's a literal expression. And if it's a region, we just use region begin and region end. Otherwise, it's a point. Otherwise, it's nothing if we're not currently using region. So what is this function? Use region, return true if the region is active. Yeah, so the region active is when I'm selecting. When I'm in the middle of selecting, I suppose this thing returns true, right? When I'm not in the middle of selecting, it returns nothing. So and in here, then what we can do is just we can take substring of the region, begin end. It's just like two numbers of the region within the thing, and then we're just using that. We can try to do something like that. But it would be kind of cool if we could combine them together with a single thing. We can do the following thing. So tasks find by HUID select. So here's the begin, here's the end, and here's the thing. Can we... I feel like we can just call that thing. So tasks find by HUID. So I'm going to evaluate the whole thing, and now I go here. So where's the task? Okay, so here's the interesting task. I selected tasks find by HUID select, and it doesn't ask anything, and it just jumps there. I wonder if something like the Embark plugins, Embark Act was added to Emacs yet. I have no idea what that is. Is that something from Vim? So how can we combine these two functions together? How we can combine? Is there any way for us to say, okay, so if you are using region, use the region. If you don't use the region, ask for HUID from the user. Is there any way for us to say that? So embark is act on thing at point but on steroids. Okay. So somebody was suggesting a very interesting thing to use completion read or whatever, right? I forgot where it was. Does anybody remember? So I suppose the idea is that maybe you can just implement functionality of interactive yourself. Yeah, completing read. Let me take a look at that. Thank you so much. Completing read. I suppose this is what interactive uses. Read a string in the min buffer with completion. Yeah. So I have a feeling that one way for us to even implement that is literally just do something like this without any interactive or anything. So if you're using region, just do that. So this is the thing. And the begin is a region begin, and region end. We can check if region is active and use completion read if not. Yeah. So this is what I want. So region, we just return that, and then completing a read. So does it have like a similar format? It accepts the prompt. Okay, so it's going to be HUID. And what is collection? collection. This collection can be a list of strings, an edit or array of hash table, can also be a function to do with completion itself. This is kind of cool, so that means we can do auto completion. Can it be nil or is null? Okay, so let me actually put a nil in here just in case. So what does it return? Returns. Okay, let me call it. Okay, so yeah, it basically asks and returns you that. What that means is that we can probably just do let HUID. So this is that, and this is something like that. So that's the thing we have. Also, find by HUID, but we're already inside. Oh, it's on. I'm looking at it incorrectly. So here's HUID, and this is the database. I'm thinking, can I merge these two things? I feel like I can. All right, so this is that. So first, but I'm not sure if it's going to even ask. Well, it will ask first because we check for this database only after all that. So if it's a use region, we're going to do that. Otherwise, we're going to do that. All right, so that's an interesting approach. I kind of like it. So where's the task? Where's the task? Okay, so if I just call it like this. Oh, fuck. Wrong number of arguments. Okay. So it's just like because it accepts one argument. All right, one more time. Find by HUID. I don't have a HUID. Okay. Task by HUID. Provide that. Jump there. Cool. But now, if I just select and I just say find by HUID, it finds it instantaneously. Perfect. This is much better, actually. This is much better than interactive. I like it. So thank you so much, everyone who suggested all that. So I suppose this entire thing will probably return null or nil or whatever. So let me try. I'm gonna do message. So to instantly see it. And what we're gonna be doing in here is I'm just gonna print HUID, whatever we got in here. And I'm just calling it, but then I'm canceling it. Do we have anything in messages? So when I cancel completion, what is happening? When I do Control G or whatever, I suspect that maybe in that case completion rate throws a tag, and somewhere at the higher level in the interpreter it catches that tag. So none of that code below is going to be executed, so I probably don't have to worry about it. Whole function cancels, yeah. And it's probably canceled through a throw catch mechanism, yeah. Control G is a global interrupt. Yeah, okay, so that's fine. So this is basically what I want. And it's already very close to the functionality of just clicking on the UID. It's already that, essentially. So furthermore, some of the tasks also refer to other tasks, but I wish I could find them. All right, so here's some tasks. So in here, this is a closed bug, and it was referred to other closed task. So I can just say, okay, find me that thing. There we go, I find it instantaneously. Here is another one, okay. I don't even need to turn them into links. Why turning them into links? Like, I don't need to do that. Wait, okay. So one thing I would love to add maybe is checking that UUID, like HUID, is valid, right? So you don't inject anything into the path or whatever. To turn them into links. Yeah, it would be kind of cool to turn them into links, but these two things are already immensely useful, I believe, right? So creating from a to-do and just jump in there. We can try a very interesting thing. Is like, let's try to use both of them simultaneously. I'm gonna try to find a to-do. Right, so here is to-do, relative mouse coordinates, okay. Well, this one is annoying because yeah, so it has a broken title. So merge cam, okay, let's turn that into to-do. Boom, it's turned into to-do. That's pretty cool. And then at any point, I can just do, okay, find by UID, and I can jump to it back. I think that's a win. this is basically everything that I wanted to do on today's stream, right? So, and it will simplify my work immensely, I think. And it's only 50 lines of code, 49, right? It's not that much. We spend a lot of time kind of researching how to do all of these things, but by itself, it's not that big, right? So by itself, it's not that big. That's pretty cool. Should I release this thing? Maybe I should release it. So, but if I'm going to be releasing it, I think I also need to release the spec of the tasks database, right? So, as I already said, I don't want this to be like an official application. I want it to be just a spec of a simple format of storing the tasks database, and then it's up to you like to implement the tools, right? So you can use whatever you want. Maybe make a Vim extension that works with that database directly. I want the database to be so simple that you can just implement an extension from scratch without third-party dependencies, right? So because you see in here in Emacs, we didn't need to call a C program that implemented in here. Right, so we can just work with this database directly, and that's the power of this specification. Just release the spec. Yeah, so I should just like, you know, clean it up and release the spec, and maybe a bunch of these tools as an example. Right, but apart from that, it's just like, yeah, it doesn't have to be a software. You can also search for to-dos with the completing read. I can. There's a lot of things. Maybe I can even integrate with Helm, right? So things like Helm. E-tags select or whatever. We don't even have E-tags in here, but we could. So we can find all of the files with the name that ends with C and H, right? And so just feed them into E-tags. Then if I go somewhere, I don't know. So let's find maybe the game. Here's the root. We call some of the functions in here, but then if I do E-tags, so it loaded E-tags. I can do something like this. Right, as you can see, I can search by specific names, and Helm is sort of like a framework for Emacs for these kind of auto-completion searches. We can try to hook up into its mechanisms and provide auto-completion, literally collect all of the tasks and just feed them into Helm so we can search by them like that. So that's one thing we can do. Helm, is it an old thing? Man. So nobody uses it, right? So Helm is a boomer thing. You're supposed to use something else today. So, yeah. Man, I remember when it was released, for fuck's sake. Or not really released, but I remember that like everybody was regarding it as this new thing. Man, I'm so fucking old. Holy shit. So standard Emacs mechanisms are cool now. Okay, I'll look into that. I'll look into them. Better yet, use the regular Emacs completion, other packages integrate into that. Okay, all right, I'll look into that. But I think I've done everything that I wanted to do today, and already streaming for 2.5 hours, so that's enough for me. That's it for today. I hope it was fun. It was a little bit nerdy, right? So I suppose not everybody understood what I was doing. It's kind of weird language. I understand that. Thanks everyone for watching. Have a good one, and I see you all on the next recreation programming session. Bye. With who? I missed that as well. Love you.